Please welcome Go programmer Andrew Gerrand.
Hello, everybody. Thank you for coming. It is my great pleasure to be here in Yokohama to speak with so many of you talented developers from Japan's excellent developer community. I'm really excited to be here. My name is Andrew Gerrand, and I work on the Go programming language at Google in Sydney. I'm also a developer advocate, part of Google's developer relations team. And if you're interested in following me, I'm on Google+ and on Twitter. Those are my names. In this talk today, I'm going to speak about App Engine and the new Go runtime for App Engine, and some of App Engine's core technologies and services, and the Google Cloud Storage platform. And I'm going to demonstrate these in the context of a full application that does something interesting. So how many of you here use App Engine? A lot of you? So you're quite familiar with the App Engine stuff. Who here doesn't know about App Engine at all? Anyone? All right, great. So just to briefly describe what App Engine is, I won't dwell too long on this. App Engine is a platform as a service. So it allows you to use Google's infrastructure to build scalable and reliable web applications. So it means that you can focus on the development of your application and not worry too much about the system administration and managing machines and provisioning and all of those boring, frustrating operational tasks that make development more difficult. And another great benefit of App Engine and these kind of platforms is that you pay only for what you use, so it can be much cheaper than using other infrastructure. App Engine has a number of built-in services. The biggest and sort of most fundamental of which is the data store, which is an indexed data store, kind of like SQL, but has a different set of trade-offs. There's the blob store, which is used for storing large binary objects. The channel API, which we'll look at today, for pushing data from the server to client front ends. There are task queues for scheduling tasks to be run outside of a user request and to do more long-lived tasks. And then there's backends, which are great for doing processes that can run for a very long time, background batch jobs. And there are also about a dozen other services, which I won't talk about today. So App Engine has been around for a few years now, almost 4 years. It's started with the Python runtime, and then later in 2008 we saw the Java runtime. Then in 2009 we saw the introduction of task queues, which added a new class, opened up App Engine to a new class of applications. And then the high replication data store came along in 2010, which is a more reliable data store, which enabled us to provide a more reliable service with less downtime. And then also in 2010, we introduced backends and pull queues, which further expanded the potential applications for App Engine apps. And then in 2011, earlier this year, we introduced the Go runtime. So the Go App Engine runtime was launched by my team at Google I/O earlier this year to trusted testers only. And then a few months later, we launched it to be generally available in July. And so anybody can use it now. And currently, the set of APIs available for Go is almost the same as those for Python and Java, but it's still behind by a little bit, but not much. So who here knows about Go? Who's heard of Go? Has anybody programming in Go? A few? That's great. Cool. So briefly, Go is a language that was born out of a frustration with the existing languages that we were using at Google. On the one hand, you have statically typed compiled languages that are very efficient and that perform very well, but can be very difficult to use And on the other hand, you have dynamic languages, which can be very productive to use. You can get a lot done, but they can not perform very well, and not having static typing, they can be difficult to manage when you get a very large code base. So we thought, why can't we make a language that is in the middle ground, a language that performs very well and that is very reliable and that allows you to build code to a large scale, but that also gives you the productiveness and the ease of use of the dynamic scripting languages. So Go is the language that compiles to native machine code. It's statically typed, but it has a lightweight syntax, so it feels like a scripting language. It has a simple type system, which is very easy to understand. And in fact, the whole language as a whole is a very simple language. It's one that you can learn the fundamentals of in quite a deep way in a very short amount of time. And Go also has some interesting concurrency primitives, which I'm not going to talk about today, but they're definitely one of the key features of the language. And Go also has the coolest mascot by far, and that's a very big one. I'm not used to seeing one quite that large, but that's him, and he's really cool. And so Go is also now one of the canonical or official languages that Google uses internally, so that's pretty exciting too. So to introduce some Go code, this is a complete Go App Engine app, the Hello World app. And so at the beginning here, we just declare the package name, which is hello. It can be any arbitrary name. And then we import fumpt, which is a string formatting package. And then we import the HTTP package. And in this init function, which gets called automatically, we associate the web root with this handler function, which is this function here. And so any web request will be handled by this function. And then we just, the function itself, uses the fprint function to write that string as the HTTP response. So that just gives you an idea of the feel of Go and how simple it is. So why would you choose to use the Go runtime? Well, the primary benefit over the Python and Java runtimes is that you get better performance. So if you have CPU-bound tasks, you can complete them a lot quicker with Go. And also, Go tends to have a much smaller memory footprint. And both of those things, with the new pricing scheme, you will actually pay for in a more fine-grained way. So you may save money using the Go runtime. The Go runtime also starts up faster. So it means if you get a sudden spike of traffic, your app can scale faster to handle the load. And as I mentioned, it's also a simpler language, and I personally think it's a better language. So I think you'll have more fun writing Go code. So the app that I'm going to demonstrate today is a ray tracer that is based on a pure Go open source ray tracer. So this is somebody else's library, and I've written a web front end to it that takes a scene description and then uses App Engine to render an image and send it back to you. So the tech I'm going to use is Go, task queues, backends, the channel API, and cloud storage. So to demonstrate how this app works, this is the app itself. As you can see, there's a scene description here, and if I press the render button, it fires off a task, and then an App Engine instance renders the image, uploads it to cloud storage, and then we see the final image. So how does all this work? This is the basic flow of what's happening in this app. Don't worry if you don't understand what all this means now. We're going to revisit this diagram and make it all clear as we progress through the app. In short, the client first retrieves the HTML and JavaScript page, and then they send a request to render the image via an AJAX request. A task is created that renders the image on a backend, and then we send the image to Google Cloud Storage and a message to the client saying the image has been rendered. And then the client retrieves the image from Google Cloud Storage. So the basic HTTP handlers, the 3 entry points into the program are first the web root, which serves HTML and JavaScript and also creates a browser channel through which we can push messages to the client. We also have the render handler, which is when you click the render button, this is what is called to create a render task. And then we have the render task itself, which uses the GoArray library to render the image, and then it uploads the image to Google Cloud Storage, and then it sends a status message through the browser channel to the client to say, here is the image. So just briefly introducing the channel API. The channel API creates a push connection between your application and the web browser. It's the same thing that Google uses for Google Chat, and it's useful for real-time games, chat, instant notifications, and more. And we're just going to use this to push messages from the back end to the client to notify them of the progress of the rendering. So when the user visits the front page, the HTTP request is handled by a root function, and the root function generates a random channel ID and then creates a channel of that ID. And then it outputs an HTML and JavaScript page using Go's template package to include the channel token and the channel ID in the JavaScript itself, so that on the JavaScript page, there is a bit of JavaScript that uses that token. That uses that token to create a new channel connection, and then it also binds a click event to the render button to make that AJAX call. So what I've just described here is this first portion here, performing the GET, and also the creation of the event that makes this request here, the AJAX request. So the next thing I need to describe is adding the task to the task queue service. So task queues, the task queue service is a feature of App Engine that is essentially just a list of pending web requests. And so apps will create requests and push them to a queue, and then the queue is executed by the task queue service outside of the main user request. And typical App Engine requests have a 60-second time limit, but tasks have a 10-minute deadline. So you can do a lot more inside a task than you can in a typical App Engine request. So the task queue service will execute each task in the queue in series, and they retry ones that fail. So if one request fails, it will back off and retry it later. And so the major benefits that you get from task queues is you can avoid request deadlines. You can do more work in a task queue than you can in a normal user request. And you can reduce the latency of user requests. So if a user updates some info that you want to write to the data store, you can do the data store write in a task queue, and then the user gets their response immediately, but maybe an expensive data store operation happens in the background. And so example uses are, if you wanted to do a bulk email, you could create a task for each email that you want to send, guaranteeing that each email will be sent. If you were implementing a web crawler, you could have a task for each URL that is to be processed, and then for each sub-URL, each task could create subtasks. Or if you're processing large amounts of data, you could create tasks to partition the data and process different parts of the data. But in this case, we're going to use task queues to do the image rendering process of this ray tracer. So the rendering will happen in the background. So the render handler, the post request to /render, is handled by a render function. And the first thing the render function does is create a task that hits /task/render, and it contains a scene variable and a channel ID variable, which is the scene description and the ID of the channel. And then it adds that task to the default queue. So what I've just described is this portion of the exchange. So our render handler here creates the render task, and the task queue service will make a separate request to task/render. So you notice here that I'm hitting a backend instance. So why do I need to hit a backend instance when instead I could just have the task queue hit a normal app instance? Well, the primary reason is speed. So backends are app instances that have no request deadlines. So you can run processes of arbitrary length on a backend. And the other feature of backends is they offer varying request sizes, instance sizes for different workloads. So the typical front end is of this size, B1, which is 128 meg of RAM limit and 600 megahertz CPU limit. The default for a backend is B2, but in this case we want maximum speed, so we're going to create a backend of size B8 to render these images, which is a very high clock speed. And so you can use backends for a variety of purposes. Say if you were building a game which had a large in-memory state, you could use a backend with a high memory limit to store that persistent game state, and then the front-end instances could consult with the backend and exchange data. Or if you had search indexes, or for doing CPU-intensive tasks, or any kind of long-running background processing, report generation, etc. But in this case, we use the backends to process our render tasks so that the images are rendered quickly. So to set up the render backend, we create a file called backends.yaml in our app root. And this is the complete contents of the backends.yaml file. It defines one backend named render, and the render backend is of the biggest size, the biggest class, B8. And this option here, dynamic, means that rather than the backend being running continuously, the backend will only be started when there is a request available for it. So you pay for backends by the hour, and so it's much more economical if I only run the backend at the times when I actually need to render images. So to deploy the backend, you just use the app CFG script with the backends verb, point it to the app directory and say update. And this deploys your app to the backend in the same way that you deploy versions of your app to App Engine normally. So the task/render handler, this is the handler that the task queue service calls. This task actually performs the rendering itself. So first, it gets the scene and channel ID from the post request, and then it uses the GoRay library to render the image, and it renders the image into this image bytes buffer. So this will be a PNG image. And then it generates an image URL by taking a hash of the scene description. So because for any given scene, the image output of that scene will be identical, we can store the output under a hash of the input value and know that we don't need to regenerate it multiple times. So we can upload, and then finally the render task uploads the rendered image to Google Cloud Storage using this put image function. And we'll talk about put image in a little while. And while all of this is happening, so when the task/render function starts, and after the rendering is completed, but before the upload is completed, and then after the upload has completed, we'll use the channel.send function to send status messages to the front end. So the front end can see rendering, render complete, etc. And finally, when the image is complete, it sends a message that begins with image : and the JavaScript front end knows to expect a message of that kind and converts it to an image tag, including the image URL instead. So instead of seeing the textual URL, the user will see the image itself. So what I've just described here is the task queue making this post call, and then the backend itself rendering the image, and it uploads the image to Google Cloud Storage. And then at every point while it's doing this, it's sending status messages through the channel service to the client. And finally, the client performs a GET from Google Cloud Storage to retrieve the image and display it on the user screen. So who here has used Google Cloud Storage? Anyone? No? Well, Google Cloud Storage is it's a scalable system for storing large objects. And you can store objects of any size in there, and you have flexible access control, so you can define groups, you can grant specific access to specific clients, and all of this is done through a simple RESTful API. And so it's useful for really anything that you would use for storing data. In this case, we're storing some user-generated content, but you could be storing video, music, indexes, anything that requires data storage. And this is the same technology that we use for storing images, say for Picasa, or really anything of Google's that stores this large data. So you know that this service is going to be reliable and that your data is going to be safe in it. So the put image function that uploads to Google Cloud Storage, the first thing it does is retrieve some OAuth tokens from the data store, which I'd stored earlier. And it uses these to authenticate with the Google Cloud Storage API. And it does this by creating a HTTP transport that takes the authentication tokens and also takes a URL fetch transport and binds them together to create an authenticated OAuth transport. Then what the function does is create a put request, and the put request sets an ACL rule that the image is going to be publicly readable, and then it uses the transport T. It uses the transport T to make a request. Make that request, uploading the image, and in response, it checks to see that it got an OK response, and if it did, it means the image was uploaded correctly. So I've kind of skimmed over a little of the OAuth flow stuff, but there's a video of Rob Pike and I at Google I/O this year called Mustachio, that has a much more in-depth explanation of OAuth authentication. So just to recap, to explain what's going on now that we have some context, and I'll just change a few of these values in here so we can see that it's actually doing something. When I loaded this page, the channel was created, and when I click render, I'm creating a task, and the back end has picked up that task and it's sent a message saying rendering, and it's rendering that image. It's rendering that image. Oh. No, yeah, oh. So what actually happened, and this is interesting, is that something must have happened to that back end and the image rendering was interrupted, and the task queue service has noticed that the request has failed, and then it retried the task. And so when the second rendering notice came up, it meant that the back end had tried again, and this time the request has succeeded. And so by using basically this shows that each part of this system is independent, and very easily we've designed a system that is not deeply coupled to any other part of the system. And so it means that even if that task failed, the design of the services ensures that I can keep doing the work and that everything will still fit together in the end. So I didn't need to refresh this page when it failed. The backend still had my channel ID, so it could still talk to me. And so in the end, I got my pretty strange looking image. So that's the talk. You can see the full source code of this app at this address, the Google Code Project Go-Ray. Yeah, you might want to take a photo of this slide if you like. The app itself is available at goray.appspot.com, so you can play with that if you like. The slides for this presentation are available at this URL, so if you want to walk through it afterwards. And also the GoRay package itself, which is, again, not my code, but another author has written this open source pure Go ray tracing package, and that's available there. And if you want to learn Go itself, if you've never used Go, there is a tour of Go, which is an interactive Go tutorial, and it's fully web-based, so you don't even need to leave the comfort of your web browser. And better still, there is a Japanese translation, so you can go through and learn about Go and run your code right here in the browser. And there's a series of exercises, and it's a really great and easy way to learn Go. So you should check that out. Especially nice to have the Japanese translation. The Go website has many articles and lots of tutorials and code walks and other documentation. The Go blog has a huge number of other articles and a lot of in-depth discussion of Go the language and using Go. And finally, Go for App Engine is available via its documentation here. And so, yeah, thank you very much. ありがとうございました。